This is Unit 7, Lesson 7.5, Tangents to a Circle. It is really important today that you have a straight edge handy, so make sure you have a straight edge handy. Taking a look here, as I read, it's important that you underline or highlight keywords and phrases with me. It says, draw a circle P with a diameter going through P. Point Y is on the circle between LM, creating a semicircle LYM. If the measure of angle LMY is 34 degrees, find the measure of the arc YM. So we did the highlight, now we're going to draw one step at a time. It says, draw a circle P. Well, P, that implies, is the exact middle, with a diameter LM. So diameter LM. We're going to go through P here. And as you write stuff down, make sure you cross it out. Now it says right here, point Y is on the circle between LM, creating a semicircle LYM. So LYM is going to be a semicircle. So here's Y. And let's check. LYM has to be a semicircle, so trace through it. And yes, that is a semicircle. Cross that out. Now, last one, it says, if the measure of LMY is 34 degrees, so L, this is shoulder, elbow, wrist, L, M, Y, in that order, L, M, Y. If that is 34 degrees, we are asked to find the arc Y to M. So we're going to sweep this and question mark. That is what we're trying to find. So what I'm going to do is to set the timer for 2 minutes, and I'd like to see what you can do in 2 minutes. And actually, I'm going to make it 1 minute. Let's make it 1 minute. See what you can do to find that pink arc in 1 minute. Okay, we learned last class that an inscribed angle is half of the arc. That the angle is half of the arc. So this arc has to be 34 times 2, so it's going to obviously be 68. And then here, this is 180. So we're going to do 180 minus 68. And we get 112. Obviously, this wasn't drawn to scale. That's okay, as long as you understand that the inscribed angle is half the arc semicircles 180, and you simply subtract. Okay, let's go on to something new today. Read and check the key vocabulary words for today. We're going to be talking about circle tangent. So we're going to talk about the word tangent, radius, chord, the tantan angle, the tan chord angle, and of course a right angle. Please get a straight edge. Here's the main concept you need to know today, main concept. Okay, if you had a wheel, here we have a wheel with spokes, with radii. Trace a couple radii here, the spokes in the wheel. So there's a spoke, there's a spoke. Now this wheel touches the ground. I'd like you to trace the ground, please. It touches the ground, so trace the ground. It touches the ground at a single point. So I'd like you to put a dot at that single point that it touches the ground. That single point is called a point of tangency. You want to write that down and label it. That point where that wheel touches the ground is called the point of tangency. Now I'd like you to draw on the radius to that point of tangency. So from the center of the circle, draw in the radius that meets that point of tangency. Now you should kind of notice here, if you trace with me, go ahead and trace that radius to the point of tangency. Now trace the ground again. Do it again. Trace the radius to the point of tangency. Trace the ground. One more time. Trace the radius to the point of tangency. Trace the ground. There's a certain kind of angle there. Go ahead and mark what angle you think is going on there. I'll take about 10 seconds here. You should have marked that as a right angle. If you look very carefully, the radius to the point of tangency and where it touches the ground does create a right angle. That is the key to today's entire lesson, is this simple concept. Okay, when you have a radius, trace a radius, make a point at the end of that radius. Now get out your ruler and draw a tangent that goes through that point. A tangent that goes through that point. That radius and that tangent create a right angle. This is so important. We have another jingle yet again. I'd like you to watch very carefully as I sing this jingle and what I trace. I'm just going to say it first. If tangent to a radius, radius, radius. If tangent to a radius, right angle at the edge. Just watch this first time. Watch what I trace. And watch what I sing. If tangent to a radius, radius, radius. If tangent to a radius, right angle at the edge. Okay, I'm going to sing it again, and this time I'd like you to trace with me. Trace with me. There's our tangent, there's our radius, there's our point of tangency. So when you see the word tangent, I'd like you to trace it. When you see the word radius, I'd like you to trace that. Ready? If you didn't figure that out, that's Mary Had a Little Lamb. If tangent to a radius, radius, radius. If tangent to a radius, right angle at the edge. Okay, see if you can't find that. So all of today's lesson depends on your ability to find that tangent. and the radius. So here, what I'd like you to do in this diagram, I'd like you to find any right angle that's there. I'd like you to trace the tangent, darken the point of tangency, trace the radius, and then we're going to sing. So one step at a time. First, we're going to trace the tangent. Tangent is a line that touches from the outside at only one point. So get out your straight edge, and your tangent's going to be AD, and you're welcome to stretch it out just as a habit there. A to D is your tangent. Okay, now we're going to darken the point of tangency. Our point of tangency is point A. Now we're going to trace the radius. From O to A is the radius to that point of tangency. So AO is the radius there. Now trace and sing with me at the same time. If tangent to a radius, 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 if tangent to a radius, right angle at the edge. So where you have a tangent and a radius, they meet at a right angle at the edge of the circle. Okay, I'm going to give you a minute here. I want you to find any right angles that belong here. You find it yourself, and then we'll see if you can identify. I'm going to give you a minute to do so. Make sure you trace and sing at the same time. You should be singing. The song goes, if tangent to a radius, 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 if tangent to a radius, right angle at the edge. Do both diagrams. All right, let's take a look and see if you got the right angles in the right place. Taking a look here. Here's our tangent right there. There is our point of tangency at A, and our radius is right there. So we have a right angle at the edge. That is the only right angle in that diagram, because that is the only tangent. Now down here, if you haven't done so already, I'd like you to take a moment, put those right angles in where you think they belong. Tangent to a radius, right angle at the edge. Just going to give you a few seconds to try that on your own. Okay, we only again have one tangent here. I'm going to stretch it out. Get in the habit of stretching tangents out. It's a little easier to work with. So there's your tangent. Now here's your radius in this circle. And here's your radius in this circle. Here's your point of tangency in both. So it goes like this. If tangent to a radius, 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 if tangent to a radius, right angle at the edge. That's one. If tangent to a radius, 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 if tangent to a radius, right angle at the edge, that's two. Now remember when we talked about where there's right angles, there's right triangles, and when you have right triangles, you have the key to the universe. So don't be surprised, many of the problems we're going to work on today are actually right triangle problems. For example, we're going to do this one. I'm going to get you set up, and then you're going to do it on your own. So let's follow the instructions. It says trace the radius QR. So start at Q, trace that radius. Now it says trace the radius QT. Go over here, trace the radius QT. Now I want you to trace the tangent RS. RS. Go back and trace QR again. QR. Now you're going to find X. I'm going to give you 2 minutes. Your goal is to find X right there. You have 2 minutes to figure out what you can do. So you're attempting to find X in this diagram. Okay, let's see what we have so far. So the most important was this simple. Is tangent to a radius, radius, radius? If tangent to a radius, right angle at the edge. Where there's a right angle, we have a right triangle. We're going to pull that out. So here's our right triangle. Here's our X. There's our 12. The only trick to this was to ask ourselves, how do we get this hypo? Well, look very carefully. Hopefully by tracing you felt that if that's 12, this is 12. And then we go like that, and we add 12 plus 8, that's 20. So now we can use the Pythagorean Theorem, which is leg squared plus leg squared equals hypo squared. So if you didn't get this far, obviously you need to now. Let's plug stuff in. Circle, plug, chug. Leg. Come over here, pick it up leg, that's going to be 12 squared, plus the other leg, which is x squared, equals the hypo, 20 squared. So x squared is going to equal 20 squared minus 12 squared. We're going to square root both sides. So x is going to equal the square root of 20 squared minus 12 squared. I'm going to pull out my calculator so you can watch the math here. So we're going to go 20 squared minus 12 squared equals, we get 256, then we square root, and we get 16. So x equals 16. Okay, there's one more concept about tangents that we need to be familiar with, and that's the Tantan angle. I call this the beach ball angle. So what I want you to imagine is, imagine that this right here is one giant beach ball. So angle DCB is made up of two tangents. Tangents come from the outside and have a point of tangency. So CD and CB are arms of a tantan angle. This is a tangent. This is a tangent. So this angle right here, DCB, this angle right there, is called a tangent tan angle, or I will shorten it to a tantan. And real simple concept here is the fact that the arms of a tantan angle are always going to be congruent. This length here, this arm here, compared to this arm here, the arms of a tantan angle are congruent, so you hatch mark it. What you want to visualize, if you yourself were holding a beach ball, one on one side, imagine that dot on the other, the arms touching that beach ball, your arms here, one on one side, one on the other side, those arms are going to be congruent. So the arms of a tantan angle are congruent. So here we have this diagram. We want to solve for x. First, trace your tantan angle. So B to A, darken it, and B to C. This is a tantan angle. This is a tantan. We just learned that the arms of a tantan angle are congruent, so hatch mark. So you write, remember we do things first, so you write arm is equal to arm here. One arm of the tantan is equal to the other arm. Now, circle, plug, chug. Follow with me. Never ever be happy with just solving for x. Always see if there's something you can do with x, which in this case, we can easily plug it in and make sure that it does work. So we're going to say x is 6. So up here we're going to go 4 times 6 minus 9. 4 times 6 is 24 minus 9. Yes, that's 15. And this is 15. We know. Now we've checked it. Okay, let's do this one together. This is a really easy problem. Make sure you follow my instructions. I want you to trace A to E, please. Now trace A to D. If you can, switch colors. Trace B to E or squiggle. Trace B to F. Now trace C to F. Trace C to D. Your goal is to find the perimeter of ABC. So this is your goal. I'm going to trace it in yellow here. You want to find the perimeter of the triangle A, B, C. Also, you want to draw in the radii GE, GD, and GF and find the right angles. I'm going to give you 1 minute to do both. Go. All right, let's see how you did. We learned that the arms of the Tantan angle are equal, so if that's 6, this is 6. Over here, if that's 7, this is 7. And then over here, if this is 4, this is 4. So to get the perimeter, we simply add these up. We're going to go 4 plus 6, that's 10. 6 plus 7, that's 13. 4 plus 7, that's 11. So 10 plus 11 is 21. Plus 3 is 24. Plus 10 is 34. So the perimeter is 34 units. Now as far as the radii, you want to draw in one radii, right angle. Another radii, right angle. Another radii, right angle. There is your right angles. So far there are actually 4 types of angles we've covered. 4 types of angles. Let's go over those real quick. First one is the central angle. So darken the center and draw in a pie slice. That's a central angle. And we learned before that that angle equals the arc. Measure of a central angle to its arc the same. That's a central angle. Then last class, we talked about an inscribed angle where the vertex is on and the arms are in. And in this one, we learned that this angle back here is half the arc it grabs. So we do this. In this case, angle equals half the arc. So the song went, measure of a central angle to its arc the same. The smaller angle of inscribed is half the arc its plane. So that's the 2 angles we've covered so far. Then I introduced actually 2 new angles here. We're just going to draw them. One is a tan chord, so draw yourself a tangent. Darken the point of tangency. That's a tangent. Now a chord is a segment whose endpoints are on the circle. So let's just draw another point there. That's a chord. So why don't we label that? This is a tangent. This is a chord. Can you sweep that angle right there? That angle is called a tan chord. Last one is a tantan. So we have 2 tangents coming from the outside. So draw one tangent. Draw another tangent. Darken those points of tangency. The angle can stop at those points of tangency or go through. It doesn't matter. But back here, that's called a tantan. You need to be able to recognize and draw all 4 of these angles.